Okay, so welcome everyone. Today we're privileged to have Alan Kirman speak to us. And as you can see here, he's the Chief Advisor to the OECD. He's also Emeritus Professor at the University of Marseille. I don't know if I'm pronouncing that correctly. And he's a leader at the Institute for New Economic Thinking. I think for quite some time now, he's been advocating strongly for what he calls complexity economics, on which he's literally written the book. And we look forward to hearing about crises in a complex world. Thank you. Go ahead.
Okay, thank you, Jonas. Well, it's a pleasure to be back in Amsterdam. Now, I apologize right from the start that you people are much too sophisticated for the level at which I'm going to talk, but that will mean that you don't have to think too hard. So I think we should start right out from what economics has been like and the framework that it works in, and maybe what we should be doing. So let me start with what I think we could call the standard approach. Can everybody hear me okay?
Yes, it's fine.
Good, okay. So the first thing that we're told when we're students is that our models must be built on sound micro foundations. That means to say we make assumptions about the individual participants, components of the system. And indeed, Lucas, a Nobel Prize winner in economics, said that one should only make assumptions about individual characteristics, never anything about behavior of the whole. Third, individuals should satisfy economists' axioms of rationality. Now, those axioms of rationality come from economists' introspection and not from observation of how people actually reason. They should optimize in isolation, essentially. That is, they don't interact directly with other individuals. They may interact through institutions like the market, but not directly. They understand the economy they function in. So think of this as a sort of gigantic stochastic process, and these guys all understand the nature of that stochastic process. And aggregate behavior is often thought of as being like that of a rational representative agent. Something like maybe the mean field approach in physics, although that would be unfair to physics to say that. Okay, now I am going to argue later on for viewing the economy very differently, as one in which individuals follow simple rules, they adapt to their environment, they're not irrational, and they don't act against their own interest, but they're not rational in the sense of economists. They have limited and largely local information, and aggregate behavior emerges from the interaction between the individuals. And I would argue that the main problem in economics is not efficiency, which is normally thought of as being the main problem, but rather coordination. How do the activities of all these people who have limited and local knowledge and interact locally and globally, of course, how do they manage to coordinate those activities so that something sort of systematic actually emerges from that? So what has the COVID-19 pandemic revealed about our approach to economics? Well, I think what's happened is that the standard framework in economics, when you look at the system as it stands, it doesn't tell us much about what's going on in the economy at the moment. And I think one argument is, well, the global patient, if you like, that is the system, is really ill. And the current system symptoms that we see reveal clearly that that's not just a new shock, but it's the evidence of fundamental pre-existing problems which have been latent for a long time, but which somehow paper over and somehow patch up and get on with it. But each of them, I think, each of these problems shows that the framework which we use as our benchmark is not functioning as it's claimed to. So we had a recent symposium at the OECD run by this group, the New Approaches to Economic Challenges, and a number of leading authorities each explained the failure of some aspect of our so-called benchmark model. So here are the people, some of the people who were involved. This was a couple of days ago. Paul Krugman, who those of you who occasionally look at the New York Times may remember, Nobel Prize in economics. Mark Carney, the governor of the Bank of Canada, and also of the Bank of England. And Gita Gopinath, who's a chief economist at the IMF, Ken Rogoff in Harvard, who wrote a book called This Time is Different, talking about crises, by which he meant that, of course, it's not different. And finally, Mariana Mazzucato, who argues that it's in fact the state that does a great deal of innovation and sort of propels the economy. Now, all of those people pointed to particular weaknesses with our standard framework. So given that, you might say to yourself, well, let's have a look at what it is that they were each criticizing. And I'll just give you one example. One of the things that economists do is look at equilibrium states rather than the path through different states. And I think this is a big mistake. And in particular, this comes up, and two people mentioned this sort of problem, Mark Carney and Ken Rogoff from Harvard. And I think the point is that it's not of much interest to look at the world when it's 3 degrees warmer than it is now, as if we could then say, well, how will we sort of sort it out in that state? The problem is that the dynamics are such that if ever we get to 3 degrees warmer, it won't stay like that. The dynamics are such that it's going to change and continue and probably get worse. And there's no invisible hand in the climate system which automatically stabilizes it, just as there isn't in our socio-economic system. But of course, all of our analysis is based on the idea that there is such an invisible hand. And if you ask people what it is, well, they say, well, it's the markets. But they don't explain to you exactly how the markets do, in fact, stabilize the system. And so I think it's useful for us to look at what's happening in the physical environment and our contribution to its evolution. And then we have two complex systems interacting, the socio-economic system and the climate system, and they are no longer sort of independent of each other. Adam Smith talked about the invisible hand of Jupiter when there were storms and so forth, but I don't think we can treat any more those two complex systems as sort of independent, which occasionally interact. So the question is, why have we built this particular framework? And is it the right framework to have? And of course, I'm going to come to the point that I suggest that it's not the right framework. And here's an example, speech by Mario Draghi, now Prime Minister of Italy, used to be President of the European Central Bank. And he was talking about the Euro crisis. And he said, the first thing that came to mind was something people said many years ago and stopped saying it. The Euro is like a bumblebee. This is a mystery of nature because it shouldn't fly, but instead it does. So the Euro was a bumblebee that flew very well for several years. And now, and I think people ask how come, probably there was something in the atmosphere, in the air that made the bumblebee fly. Now something must have changed in the air. And we know what after the financial crisis. The bumblebee would have to graduate to being a real bee. And that's what it's doing. But for most people, they would find this very strange because actually the bumblebee does fly. And yet you say to yourself, well, however did we say that we had some sort of model which said it couldn't fly? And I thought this was an urban myth, but in fact, there's a book in the 1930s by a physicist who proves that the bumblebee can't fly. Luckily, bumblebees haven't read that book. But here you see Mario Draghi explaining to the Euro, the bumblebee, are you sure you want to keep on doing this? Because obviously you don't respect what our model says you should be doing. And I think we're so wedded to our models that they don't correspond to, when they don't correspond to empirical reality, we wonder what the problem with the evidence is, not what the problem with our models is. So what is this belief that there's a sort of stabilizing invisible hand? Well, Alan Greenspan in 2007 actually said, 2010, with notably rare exceptions, 2008, for example, the global invisible hand has created relatively stable exchange rates, interest rates, prices, and wage rates. Some nasty person on the blog said, with notably rare exceptions, Germany remained largely at peace with its neighbors during the 20th century. And some even nastier person said, with notably rare exceptions, Alan Greenspan has been right about everything. So the point is that the belief was that there was this invisible hand there. And of course, this is something we inherited from Adam Smith, even from Hume. and it's carried over, but nobody has actually explained what precisely the mechanism is that does that stabilizing. And this invisible hand, of course, you always have to show things you're talking about. So there it is, the invisible hand. And the point is, what is this mechanism? And people will tell you it's the markets, but then they have to say to you, how do the markets act in such a way that an economy or a socio-economic system that's out of equilibrium will get into equilibrium? And unless we have a satisfactory explanation for that, this just becomes a belief. And what happens if there is no invisible hand? Then who is doing the adjusting, which is supposed to be done by the invisible hand? Where will the process go? Will it converge to anything? Should the government intervene to guide it? And what about self-organization? The myth behind the economic model is that if you leave people or particles or whatever it is, the components of a system to their own devices, then they will self-organize into a satisfactory situation. And that's the sort of underlying myth on which economics is based. But when we had the financial crisis in 2008, the economist had modern economic theory melting down like a chocolate ice cream. And it said where it went wrong and how the crisis is changing it. But in fact, it really didn't get changed very much. And modern economic theory has still not really, in some sense, adapted itself to the world as it's evolving right now. So what about the nature of economic crises? Well, standard macroeconomic models don't actually contain the possibility of an endogenous crisis. The only changes that can knock it off the equilibrium track are caused by exogenous shocks. Larry Summers said it's a central pillar of both classical models and Keynesian models. It's all about fluctuations around the given mean. And what you need is to have less volatility. But once again, the fluctuations are attributed to shocks. The latter are given sort of superficial explanations, technological shocks, important and unexpected news. But the shocks are not directly measured. Not much is said about their distribution. And what we really need to know is, are they exogenous shocks or are these things endogenous? Now, what I would claim is the following. Sarah Hart, who's the new Gresham Professor of Mathematics in London, that's a claim to be the oldest chair in mathematics in the UK at least. And she says, when talking about mathematics, real mathematics involves not knowing what's going on, not having an idea what to do, then playing around and hopefully finding your way through. Finding the way often involves imposing structures and constraints on a problem. The tension is between wanting the most general result possible and actually being able to prove something. In my earlier conversation with Florian has something to do with that. You could prove hundreds of rubbish theorems about your very precise special case, but nobody would care because there's no wider implications or applications. You want just enough structure to hang your ideas on, but not so much that you're boxed in. But I think we are boxed in, and we're always trying to fit reality and our models into the variance of this benchmark model that I've told you about. Well, what is the benchmark model? It's what's called the general equilibrium model with rational individuals. People are price takers. They don't set the prices, they take the prices that have emerged somehow in the system. These people know how the world that they live in functions, and their expectations are consistent with that. Competition and markets lead the economy to an equilibrium, and despite the theoretical problems, we simply then assume that we are in equilibrium. But which of those assumptions were contested by the experts I mentioned? Whoops, sorry. I jumped the slide. Okay, but anyway, I think the point is that the people involved in our discussion, each of them took some aspect there and said, this is really not the way it really works. This is the problem with our system. We have to tweak this one. But they all took different ones. And if you have to tweak all of them, then you might start to say, shouldn't we be looking for a different framework? And that's where we come to the problem of complexity. And Stephen Hawking, who you all remember, said, I think the next century, that's our century, will be the century of complexity. Now, we actually, several of us got together and made a plea for change in the Boston Review. And first of all, there was an article by Naidu, Roderick, and Suchman who said, economics after neoliberalism. Economists should be enablers of democratic priorities, not oracles channeling a supply and demand deity. But we asked, with a whole group of people who you can see down at the bottom, including Cas Hommes from Amsterdam, we said, look, our backgrounds are in economics, political science, psychology, anthropology, physics, computer science, etc., and complex systems theory. To us, the phenomenon called the economy is a highly complex, multi-level system that encompasses human biology, human behavior, group behavior, institutions, technologies, culture, all mutually entangled in networks of nonlinear dynamic feedback. Each of these levels in the system is subject to learning, adaptation, evolutionary and co-evolutionary processes, which means that the system's constantly self-creating, never at rest. These dynamics in turn create system-level emergent behaviors, including economic growth, inequality, financial booms and busts. The whole system in turn is deeply embedded in the physical processes of our planet. This transdisciplinary perspective, sometimes referred to as complexity economics, differs in a number of significant ways from the traditional perspective of economics. That was a plea signed by quite a lot of people, some of whose names you may in fact have come across. Includes David Sloan Wilson, an evolutionary biologist, people from economics, people from agent-based models, and so forth. Now, in 2010 already, Andy Haldane, who's the chief economist at the Bank of England, who worked a lot with Bob May, a famous ecologist, he was talking about the collapse of Lehman Brothers and also comparing it with the epidemic at the time of what we called bird flu. And he said, these similarities between those two events are no coincidence. Both events were manifestations of the behavior under stress of a complex adaptive network. Complex because these networks were cat's cradles of interconnections, financial and non-financial. Adaptive because behavior in these networks was driven by interactions between optimizing but confused agents. I wouldn't have said optimizing. They are agents who are trying to get by. Seizures in the electricity grid, degradation of ecosystems, each is the spread of economics and the disintegration of the financial system, each is essentially a different branch of the same network family tree. That was said in 2010, and everybody said, well, if the person who was director of the Bank of England for financial stability was saying that, then economics will start to change. I don't think it did. And I still think that what people don't want to do is to treat the economy as an evolving, complex, adaptive system and to use computational models, because this allows us to build models which generate large, sudden, endogenous changes, but it undermines our faith in the stable self-organization of our economies. So focusing our attention on the results of the interaction between economic agents rather than on the optimizing behavior of the individuals themselves, that would represent a real paradigm shift in economics. Now, the question is, where did that paradigm come from, the one that we've been using? Well, Walras, one of our forerunners, was convinced that we were on the road to becoming a discipline like physics, and many other economists agreed. And Pareto himself, in some sense the father of mathematical economics, when examining the equations which had to be solved to determine an economic equilibrium, he said, someone well-versed in mathematics or physics would say, these equations do not seem new to me. They're old friends. They're the equations of rational mechanics. And Schumpeter, who's famous for being a person who claimed that there was creative destruction going on, that the system was changing all the time, he nevertheless said, so far as pure theory is concerned, Walras is, in my opinion, the greatest of all economists. The system of economic equilibrium, uniting as it does the quality of revolutionary creativeness with the classic qualities of classic synthesis, is the only work by an economist that will stand comparison with the achievements of theoretical physics. And I think that was precisely wrong. And I think that we got into a trap. Physics moved on, but we were left in favor of it. We left it to follow an axiomatic mathematical approach. That was the wrong path, I think. And just as a quick example, you might look at what happened in biology. And Arnold Levine, who was the head of the biology department at Harvard, explained recently, he said, well, the first paradigm shift in biology was from organismic biology, where everybody had sort of animals and things in their lab, to molecular biology, where everybody had microscopes in their lab. And he said, viewing life at the molecular level and asking questions that often ignored the organism, its natural life cycle and its interactions with the environment were things that took over. And even a colleague of his said, all of biology must be subsumed under molecular biology. All of the people working on any other form of biology were barking up the wrong tree. That tree was all dead wood. A real echo of what Lucas said, only make assumptions about individuals. But biology has moved on. And Arnold Levine said at the Institute for Advanced Studies a couple of years ago, the current paradigm shift is back to integrative or systems biology, which is being populated by individuals trained in physics, computer science, mathematics, engineering, who learn biology and work with biologists. This process of collaborative science, termed convergence by Phil Sharp, is starting to populate universities, medical schools, and research institutes. Marshall, a famous pre-runner of in economics, would have been very happy to follow it because he always claimed that biology was the right sort of analogy for economics and not physics or mathematics. But Roberto Unger, a philosopher at Harvard, said, at every level, the greatest obstacle to transforming the world is that we lack the clarity and imagination to conceive that it could be different. He's a professor of philosophy and law and was at one point a minister under Lula. So what about, why are our systems not the sort of systems that correspond to this underlying benchmark model? Well, I think the systemic threats that we face in modern societies are too complex to be eliminated or even mitigated using the traditional approaches of economic modeling and risk assessment. Those methods focus primarily on making the system more resilient to a specific and predictable threat or shock, and they're much less capable of addressing the outcomes or uncertainties stemming from social, financial, or economic interconnectivity. We are faced with radical uncertainty. That's when there are unknown unknowns. And Jean-Philippe Bouchot has pushed that one step further. He says, if we have radical uncertainty, then we're going to be faced with radical complexity. And economic systems should be modeled and managed as complex adaptive systems, using tools such as agent-based modelings and inputs from the other social sciences. And as he said, we have all heard about radical uncertainty, but radical complexity with no simple causal relations and a need to understand the components of the system and the interaction between them is the way we should go. And this is a famous quote, which I think everybody who's listening to this probably knows already, from Phil Anderson, Nobel Prize winner in physics, who said the ability to reduce everything to simple fundamental laws does not imply the ability to start from those laws and reconstruct the universe. In fact, the more the elementary particle physicists tell us about the fundamental laws, the less relevance they seem to have to the very real problems of the rest of science, much less to those of society. Indeed, at each level of complexity, entirely new properties appear, and the understanding of the new behaviors requires research, which I think is as fundamental in its nature as any other. And that, of course, that's absolutely orthogonal to the belief in economics that if you only understand the individuals well enough, you don't have to worry about the results of their interaction. But in fact, macro phenomena emerge from the interaction between the different components of the system. And you cannot understand the functioning of an anthill, for example, by studying in great detail the behavior of an individual ant. But who are these agents who inhabit our world? Well, Leon Hoffman in 1993 said, economic theory deals with incredibly smart people in unbelievably simple situations, whilst the real world is in fact more accurately described as believably simple people coping with incredibly complex systems. for example, we have this hypothesis of rational expectations. And to quote Tom Sargent, also a Nobel Prize winner, he says, all agents inside the model, the econometrician and God share the same model. But in fact, real people have very limited horizons and limited capacity for attention. So if this works, I will try and show you something here, just to show you how limited people are in terms of their attention and what may happen. So this is a very simple thing which many people here may have seen before, but the idea here is you're going to see two little teams playing basketball, and all you have to do, just watching this, is to count the number of passes that the people who are wearing white make when they play this game. So here we go. If it works, I hope.
The monkey business illusion. Count how many times the players wearing white pass the ball.
So I will shout numbers just to disturb you. 7, pi, 3, 54, 61, 90, 15, 1, 7, 19, 34, 23, 21, 16, 5, 11, 12, 13, 15. And there you go.
The correct answer is 16 passes.
And many of you may have got that.
Did you spot the gorilla? For people who haven't seen or heard about a video like this before, about half missed the gorilla. If you knew about the gorilla, you probably saw it. But did you notice the curtain changing color or the player on the black team leaving the game?
So they run it again.
Let's rewind and watch it again. Here comes the gorilla, and there goes a player, and the curtain is changing from red to gold. When you're looking for a gorilla, you often miss other unexpected events. And that's the monkey business illusion.
Okay, so the point of that is to show you that people have limited spans of attention. When they're concentrating on one problem, they tend to miss other things that are going on. And in particular there, what you observe is something very interesting. Those guys who've seen this little film before, the original version of it, will remember that there was a gorilla and they will look for the gorilla. But because they look for the gorilla, more of those people miss the curtain changing color and a person disappearing from one team than they do if they came to it fresh. So in other words, your limited attention is focused on one thing. We don't, in economics, we assume that we're paying attention to everything all the time. And that's clearly a very oversimplifying assumption. So we're not dealing with that sort of person. Next thing I wanted to show you very rapidly was the idea of thresholds. Let me explain to you. Bees in a hive have to keep the hive at a certain temperature. How do they do that? They do that by beating their wings and driving air through the hive. Now, what happens when it gets hotter? Well, if you were an economist, you'd pick up the average bee and you'd have a look at him and say, well, how can he do this? The only way he could do that would be if, as the temperature rose, he beat his wings faster and faster. And yet, that's not actually what happens. So here you can just see it going on. So here are these guys beating their wings, and you can see that actually it's not super efficient. These other guys are getting in the way, but nevertheless, it's achieving the overall goal. And so you can see that they still manage to get the air through the head, but there are all sorts of people who just don't seem to quite get the system. And they're running around in the middle as well. But there's an important lesson to be learned here. The fact is, if I took up the individual bee and I would say, well, as the temperature goes up, he beats his wings faster and faster. That's not what happens. Bees beat their wings at a constant speed, with a constant number of beats per minute, but they're either on or off. either they're doing that or they're not doing it. And what happens is as the temperature rises, more bees join in. So everybody, all the bees have different thresholds. In fact, the bees are not homogeneous. They're simple, but it's the heterogeneous quality of these bees that means that the hive as a whole has a sort of smooth reaction to what's going on, whereas at the aggregate level, but each individual is either just on or off. And now you might ask yourself the question, well, you know, how come that happened? Where did this heterogeneity come from? But you could also ask, what happened if all the bees had the same thresholds? That is that, you know, the system had evolved, so they all got the ideal threshold. Well, then we'd be back to the possibility with humans of a sort of catastrophe. You know, the famous flash crash on the stock market in May the 6th, 2010, was exactly due to the fact that people did have thresholds. What were those thresholds? When the price gets to a certain level, if everybody has different thresholds, that won't cause a huge problem. But if you have the same threshold for everybody, then that's a disaster. And also what may happen is when one person starts to sell, then the price drops to the threshold for the next person and so forth, and you get a cascading series of thresholds. So that's an important fact which is not there in most economic models, the fact that people are heterogeneous in that way. But heterogeneity is a problem that we meet everywhere in all sorts of disciplines. And as this doctor said, we're ambivalent about it in medicine. We actively suppress it, ignore it, tune it out, because doing so is crucial for establishing the efficacy of tests, drugs, and procedures. But heterogeneity is ubiquitous in complex systems, including all of biology and human society. We recognize that suppressing it exacts a heavy price and struggle to take it into account. In fact, nowadays with big data, people have said, oh, well, we can get better and better forecasts for example, life expectancy for a particular disease. But in fact, what we should be doing is not looking at for a general expectancy. We should condition it on the particular individuals involved. And once we do that, we get very different results depending on the nature of the individual involved. So there are two sorts of heterogeneity, and this is an interesting problem for economics, because there's intrinsic heterogeneity. People are indeed different. Otherwise, economics will be a totally uninteresting subject. But people have an intrinsic tendency also to imitate each other, and that can produce herd behavior where they all behave in a similar way. And of course, that is an important problem, because that means that people can herd on what may be quite a completely wrong answer. So here I want to show you something about heterogeneity and how it can also be swamped by this tendency to herd. In fact, it was Poincaré who said, when he was the referee for Bachelier's original thesis on the efficient market. Well, it wasn't called the efficient markets hypothesis at the time, but in 1900, he was the referee for the thesis. And he said, you know, your thesis is great, very good mathematics, but it has no application to reality, because unfortunately, human beings have a tendency, which you can't escape, which is to behave like sheep. And once you have that tendency, then the old idea that we had, which was that people look at their information, act upon their information individually, and then their action reveals their information to other people. And that's how information gets out into the population. Unfortunately, as Poincaré said, they have a terrible tendency to look at each other and follow what the others are doing. So here's a little clip, which from a film some of you may have seen, The Life of Brian. And that's exactly about that problem. So listen to this. You get the idea. The problem is that, in fact, people do have a strong tendency to follow each other. And this is a picture of people on Times Square, and a group of students, in fact. originally stood there, and there weren't that many of them, and they looked up at the sky. So other people came and they started to look up at the sky too, because people are not just standing around looking up at the sky, right? They're actually looking, there must be something up there to see. So these people here infer that there's something to see. And by the time this had finished, 5,000 people were looking up at the sky, although there was actually nothing to see. And this could be carried over into financial markets, the same problem. Oops. So you see this little cartoon here starts out with a man who says, I've got a stock here that could really excel. Really excel? Sell? Sell? And they all go mad and sell, sell, sell. So down at the bottom here, you have a guy who says, this is madness. I can't take it anymore. Goodbye. Goodbye. Buy. And off it goes again. See, buy, buy, buy. And then finally down in the bottom corner here, you can see that you've got a guy who says, I've got a stock here. And off we go again. But the whole point is that once you start to have these this herd sort of behavior, you get a very different outcome than you would in a world in which people are acting independently on their own information. So here's a very quick example. How am I doing for time, Janice?
Yeah, you still have, I would say, 20 minutes.
Okay, very good. I'll actually finish on time for once. Good. Okay, so here's a very simple example in which what I want to show you is that you can build models which capture the role of the interaction between individuals, their local rationality, and the impact that that has on the evolution of the market or the economy. The idea of this example is to show you how a gradual but rational adoption of rules at the individual level can lead to radical changes at the aggregate level. Again, it's a sort of phenomenon of herd behavior, but let me explain it to you. Up until 2006, house prices in the US, in these major cities, you can see Los Angeles, San Francisco, Dallas, and Boston, for example, were all rising. But in 2006, beginning 2007, they started to collapse. Well, not to collapse, but at least to decrease. Now, at the same time, a huge market was developing in so-called mortgage-based securities, which are complicated credit derivative products. And as you know, what happens is a bank will actually lend to somebody, give them a mortgage on their house. And then what you do is you take all the mortgages that you created in this way, you split them up and you put them in a parcel into an instrument which is called a mortgage-based security. But that means that when you buy one of those instruments, it's got maybe hundreds of mortgages underlying it. So now what do? So you say to yourself, well, should I buy this or not? And then the question is, well, what could go wrong? Maybe some of these mortgages have gone wrong, and maybe they're toxic. So maybe I shouldn't buy it. But if I'm not sure, I should surely check on the underlying. But checking on hundreds of mortgages is a very costly process. So the question is, will people actually check, or will they not check? And what happened is here, you can see something very important. If you look in the second part, in the middle of this diagram, you can see that, look at a mortgage that was issued in 2003. After 60 months, that's 5 years, then you see that 15% of those had gone bad. By gone bad, I mean either the payments weren't being made or the person has just given the house back to the bank. But now look at 2007. In 2007, after 10 months, nearly 25% of all the mortgages had gone wrong. Now that was information that was known. People could have found that out. And why were they continuing to invest then in these mortgage-backed securities when so many of them were going wrong and the mortgages were underlying them? But what actually happened, as you see in this third diagram, is that the prices remained absolutely flat and then suddenly start to collapse. But the ones that collapsed first were those that were rated very highly. The ones that collapsed second were rated very badly. And the second ones are the ones that were rated somewhat better. And the last ones to collapse were those who got AAA ratings. So you can see what's happened here. But now the question is, how do we explain that? Well, the idea is that why would you not buy one of these things? Because you're afraid that when you do buy it and it's got bad mortgages, the guy who wants to buy it may check. And if he checks, then he may see that there are things wrong and he won't want to buy it and you won't better sell it at a reasonable price. And so the question was, people looked around at the other people in the market and said, are they checking or not? And if they found that the people that they dealt with were not checking, then they would buy and the thing would just be self-sustaining. So you're in a sort of self-sustaining equilibrium. When somebody starts to check, at that point, other people notice that he's checking and therefore they start to check and the price spirals downwards. So we made a very simple model of that with a physicist and a person who was at the time at the Bank of Canada, Central Bank of Canada. And so what we did was we made it as a little simple a model, and we found that there were two sorts of equilibria. There was an equilibria in which everybody keeps trading, even though the mortgages are all going bad, and nobody checks. Or there's an equilibrium in which everybody starts to check, and then the prices collapse as then the toxic assets become apparent. And then the question is, which equilibrium would we get into? And that, of course, our little model didn't explain until we added some noise. And then we had to simulate the system. And so what we did was exactly that. When we added a little bit of noise, first of all, the system would sort of settle to the situation wherever nobody was checking. But you add a bit more noise, and then it only takes one or two people to start checking, a little bit more noise, and then all of a sudden the system collapses. So that's exactly what seems to have happened. You know, the people were not making an absolutely clear and analytical decision. And there we chose that particular logic form for the probability. But so you can see that the system collapsed from one sort of equilibrium into another. And then you go back to the story that I was telling you about, and all you needed for that to happen was that the probability of something being toxic just became a little higher. And together with the noise in the system, what will happen is exactly what we've seen, that the mortgage-backed securities will stay at one price as long as you're in the first equilibrium and then switch rapidly and collapse. Just as a sideline, you notice that the last ones to collapse were the ones that were very highly rated. But those ratings, ex post, somebody looked at how good were those ratings as a forecast of how many of the underlying mortgages were toxic. And the fact was that the ones with AAA ratings were had about the same proportion of toxic assets as the ones which had BBB ratings. So they were not actually a good signal, but they were enough to keep people trading and not checking. And so it was just the rating, which was a totally uncorrelated signal, in fact. And of course, the rating authorities got into a lot of trouble for that. So that was a simple model that we built with Matteo Marsili, who's a physicist in Trieste, and with Kartik Anand, who at the time was at the Bank of Canada. Okay, so now the next thing is, let's look at how people actually behave. And you remember this famous quote from Isaac Newton. Of course, he lost a lot of money in the South Sea bubble, but he says, I can calculate the motion of heavenly bodies, but not the madness of people. And here's, of course, is a perfect example of the madness of people. Many apparently reasonable people who at home were nice to their children and everything, got into this crazy attack on the Capitol where they all wanted to hang the vice president, you may remember. And the question is, how can that sort of thing happen? And that's another thing that we don't take care of in our standard model, but it's a very important thing to consider. And it's, in fact, as you may remember, the underlying phenomena there was the fake news, the news that Donald Trump tried to perpetrate, even though the elections were being verified, being certified, that he had in fact won the election and that it was being taken away from the people. And he was stimulating that. And that fake news was circulating very heavily on Twitter. And there was a study published in Science magazine in 2018, which looked at 12 years of Twitter data. And what they found was fake news stories diffused significantly farther, faster, deeper, and more broadly than the truth in all categories of information. And true stories took about 6 times longer to reach 1,500 people on Twitter than hoax stories, according to that study. And of course, that's Jonathan Swift in the 18th century said, falsehood flies and the truth comes limping after it. But the point is, in fact, how do you study that? Well, you look at people who retweet, because that's a very good indication. People retweet things that they agree with. And it's a good indication of what's going on when you want to know how news is spreading. So this is really bad news, because this suggested that fake news is going to sort of take over. But actually, David Chevarrias at the Institute for Complexity in Paris did a study on voting in the presidential election and looked at the impact of fake news. And what he found was something very different from what was said in the Science article. Fake news spreads very fast to people who are already predisposed to believe in it. So in other words, there was a piece of fake news which said that Alain Juppé, who was a possible candidate, presidential candidate, he agreed to have a mosque built in his town, Bordeaux, and immediately was accused of being a sort of covered up Muslim, believer in the Muslim religion. And there you see a picture of Ali Juppé. But the interesting thing is, if you look at the people, the groups that formed amongst people who retweet, those who were, let's say, on the right, it spread very fast, that story. But the people center and left virtually didn't even take any notice of that. So what happens is not that fake news takes over, but it has a heavy polarizing effect on society. People tend to cluster much more than they did in the good old days, where you just had sort of 1 or 2 sources of information, the newspaper and the main news on television. And now people tend to polarize much more on these different sort of stories, and some of them, of course, are fake. So let's move on to last story. What I would claim is that we should be more and more worried about endogenous catastrophes. And here's the famous Texas freeze, which happened recently, you may remember, which caused a huge disruption in Texas. And that, of course, has been put down to the increased volatility of the climate under climate change, which, of course, for which we are partially, or at least, responsible. So their system, as they had developed it in Texas, was fairly resilient, and they had also cut themselves off from the national power grid. So they couldn't pick up electricity when they needed it in this crisis. And the system was short-term efficient, but not at all resilient. And I think that's one of the problems with the sort of systems that we have built up in economics to look at things. And we're worried about efficiency in the short term. We're not very much worried about its capacity to withstand things that emerge. And in some sense, they emerge from within, because it was we who were part of the cause of this phenomenon. And now I'd like to finish with a quote in 1991 from Frank Hahn. Now, Frank was a pure theoretical economist. I don't think he even ever went to the market with his wife, Dorothy. But what he said when asked in 1991 by the Economic Journal, what will economics look like in the next 100 years? And remember, this is a pure theorist, okay? He said, wildly complex systems need simulating. Interestingly enough, ideas from evolution are being applied to learning and behavior of the individual agent. There's been much interest in evolutionary algorithms designed for the computer. There are more and more convergence theorems, and then no doubt there will be more and better ones. But while there will be work for the computer scientist, I very much doubt that economists will be able to establish general propositions in any but very special examples. Again, I do not judge. Simulation, especially when based on good data, is a perfectly respectable and probably fruitful activity. Now, Frank, to have said that in 1991, people said, well, poor old Frank, he's getting a bit old now. And, you know, that's, he's gone a bit strange. But nevertheless, I think he was exactly on the right lines. And this increased my admiration for him enormously. here's a whole series of places where people are working on this sort of thing. Because typically, if you give this sort of talk to people in an economics group, they would say to you, but that's not serious. You know, all the serious stuff is being done in important institutions and so forth. So here's a long list of people, and I should maybe even add your institution to this list, of course. But the LSE has a group working on complexity. Here's the agent-based lab at NYU, Oxford University, etc., Santa Fe Institute, all these places you know about. And then people say, yeah, but that's all sort of people doing stuff in theory. Is anybody using this stuff? And there are places where it is being used: Bank of England, European Central Bank, Bundesbank, US Treasury, UK Treasury, Finance Canada, the Fed. The IME had an agent-based model of the banking system, and the World Bank Group, same thing. So this stuff is now being used and penetrating the organisms that actually build models, so, and government institutions. So it'll take time, but I think we are changing our attitude. But it really means to look at things in a very different framework than the standard one which we teach our students. And unfortunately, we still teach our students pretty much that stuff at the basic level. If anybody's interested in a little bit more, there's a book that I edited with David Sloan Wilson, an evolutionary biologist, called Complex. Oh, it's that's very, very bad. That should be Complexity and Evolution, sorry, towards a new synthesis for economics. I'll change that. So thank you very much for your attention, and I'd be happy to answer any questions you may have.
Yeah, before going to questions, let's thank Alan for a very interesting talk. So yes, maybe we can have some questions.
Yeah, I could just stop sharing my screen, right?
Yes.
Yeah. Escape. Oh, I hope I haven't cut myself off from you.
No, you should. You're still here.
I hope you can see something. There we are. So now I can get down to the bottom here somewhere. Stop share. Is that what I want? Yeah, it looks like that. Try that. There we are. Very good.
So do we have any questions? You can raise your hand in real life or in the reactions. Yes, Florian.
Alan.
Yeah.
Wouldn't you say that an additional problem of economic theory is that that theory is being used to structure our world and to design our institutions?
Absolutely. I think that's exactly the sort of feedback that actually we probably don't want. But I remember that somebody from the Harvard Business School said, if only firms would come here and take a course, then it would be much easier to analyze what they do. So that's exactly what you're saying, that in some sense, our theory has led us, I mean, for example, the idea of leaving markets to their own devices is what's governed the way in which we've privatized things, we've destructured things, precisely because we believe in the self-organization of the system. So you're absolutely right. I think it's a feedback from our models and our theory into the real world. We're imposing on the real world, or trying to impose on it, the model that we'd like to believe in, or that some people would like to believe in. And that's an additional feedback loop, which is there. Oh, Cas Thomas has arrived. Cas.
Hello, everyone. Thank you, Alan, for another beautiful talk. I haven't heard you for a while, but you had many surprising figures again and videos. I have a question about an approach in economics that is popular from a mainstream perspective, which is rational inattention. And I'd like to hear your view on it. I mean, it's somewhat related to the attention or not paying attention, like in the basketball video you showed us. Do you see the gorilla or not? And also in the mortgage-backed securities model, I mean, do people pay attention to information? So one approach to deviate from full rationality is this rational inattention model by Chris Sims and others. I'm just curious how you feel about that.
Yeah, my problem with that is that it suggests that there's a sort of rationality which says that I can sort of calculate what I should be interested in. And so in some sense, if you think about what the person has to do to decide what not to pay attention to, that doesn't seem to me a very sensible way to do it. I think if you ask me, were you to prefer some other approach, Cas, what I would say is that take the approach of Danny Kahneman, thinking fast and slow. Now there, the idea is a lot of the stuff we do is more or less automatic. We don't actually pay attention to things. We do that when we get on our bike. We don't think about how we balance ourselves and so forth. And then on the other hand, there are things where we do actually cogitate and think about, calculate about what we're doing. But I think the idea that we sort of optimally allocate our attention to the things which we should be interested in and then don't pay attention to the others, that seems to me to require even more thinking than if we sort of tried to pay attention to everything. So I'm not convinced that that simplifies the problem. I think what it does is gives people another sort of overlying level of rationality, which I don't really think that they have. You remember Pareto once said, I think people spend some of their time taking non-rational decisions and the rest of their time rationalizing them. And I think that there's something to that, rather than the idea that the guy thinks, what should I pay attention to? There was one paper which was very interesting by Roy Ragner many years ago, in which he looked at a firm that has a number of different activities going on. And it says, should I concentrate my attention on the ones which are doing well or the ones which are doing badly to try and save them? And he came to the natural conclusion, if you concentrated all your attention on the ones that were doing well, then you would have the highest expected profit. But if you concentrated all your attention on the ones that were doing badly, you had the least likelihood of going bankrupt. That's a sort of natural conclusion. But I don't think that's the right way to think of attention. I don't think that's how we work. I don't think we calculate carefully which things we should pay attention to and which we shouldn't. I think it's even more complicated than actually not trying to do that. Is
Okay,
that
thank you very much.
Any other questions?
I have one maybe. Thank you for the really interesting talk. My question would be, there is a tendency today to use a lot of database models, meaning machine learning black box models. And what is your take on this, to approach complexity using such kind of models? Is this something that should be done, or should we should be very careful to really incorporate the interactions by hand, or certain parts of the model by hand?
Yeah, I think yeah, that's an interesting question. And I think a lot of this machine learning involves somehow, often involves trying to see patterns in the data. Can I see some patterns that emerge from the data? And then can I somehow explain them? And so I look at a whole set of data coming from a lot of people interacting. And instead of saying, well, I think about how those people calculate and so forth, I try to see what patterns have emerged. And then I try to say, if I can see those patterns, then maybe in some sense I can recognize them and in some sense influence what's going on. I think it was Hayek, who's a person actually whose political opinions I'm very strongly against. But Hayek said, there are no laws in economics, there are only patterns. And our problem is to recognize the patterns. And I think that people who use machine learning are trying to do that. And Andy Haldane, the chief economist at the Bank of England, said, I would like to be like Mr. Spock, he said, in front of the huge screen with all the financial markets in the world. And I would watch this screen and then see when something was going on, something emerged. And then I would somehow understand that something was going wrong there and try and influence the thing in that direction. And I would have to see which patterns were emerging. And I could use things like machine learning to make me, to help me learn that. But I think you're also in danger, of course, of picking up patterns which don't have any real explanation. And Cass will certainly remember that there was a whole literature on believing in sunspots. And the problem there is, supposing you see a pattern emerging and you say, I think that fluctuations in the financial markets are due to sunspots. So you start to believe that. But if enough people believe that, then we come back to the underlying question from Florian, which is, if everybody starts to believe that financial activity is coordinated with sunspots, then indeed it may become coordinated because people will behave like that. So you have this feedback again. So, but I think these machine learning techniques are very interesting. But I'm always surprised that people say, yeah, but this is a way of taking the burden off the poor calculating human being and let the machine find the patterns. But when you look at how it's done, we actually train the machine to learn. And if you have ever seen, there are these huge rooms in India and elsewhere with people staring at screens, training the machine to learn to recognize certain things. So it's a strangely complex process that we train the machine to learn things, and then the machine does that. But it needs human beings to start with to train the machine. So it's all, no, it's very interesting, but I'm not sure that I would be completely happy to rely on machine learning to detect the underlying structure of the problem. That's not a very good answer to your question, but I hope it does.
Yeah, great, thanks.
I may follow up on that with the question. Let me
Sure.
the video. Thanks for this very interesting talk. And I'm wondering, following up on the question by Mauricio just now, would you say that the kind of model building that you promoted at the end of your talk, so modeling economics as a complex system, for instance, using agent-based models, would you expect that to be able to have predictive skill, to be quantitatively accurate, or is that not the aim, in your opinion, of such model building?
Yeah, this is of course, that if ever you give this talk to people like central bankers and so forth, that's their first question. You know, will we be able to predict better than standard models, right? And of course, first of all, we have to know exactly what you mean by predict better. I mean, usually we take some sort of squared differences from the realization and so forth and look at which model performed best out of sample and so forth. But my general intuition is that we're actually a bit like meteorologists and climatologists. You know, I think economists would like to be sort of able to do climatological forecasting, but in fact, it's very difficult, I think, to forecast in the short run. That's the meteorological forecasting. You know, what will happen tomorrow. That's, of course, why the stock markets move so much. But even getting the longer run things right, I think, is very difficult. It's very difficult to see exactly what sort of test we should have if the process is non-ergodic. Okay, if it's ergodic, well, you say, okay, finally you get to some sort of convergence to your understanding of the true stochastic process. But supposing it's non-ergodic, what does it mean that I will be able to actually forecast better? So I have a feeling that forecasting is not a sort of an exercise which we can hope to do satisfactorily in some sense. That I'm not being perhaps very precise, but the idea that we will finally get to a system where we're making fairly good predictions of what's going to happen in the short run or even in the long run, I think that's going to be a goal that we won't ever get to because of the nature of the system. But you may not agree with that. I don't know what discipline you come from, so.
Well, I'm in applied math, and actually I've worked a lot on problems that relate to atmosphere ocean modeling. So I think the analogy with weather forecasting and climate projection, I'm not sure if we can ever call it climate forecasting, is very, very interesting. But I think when it comes to weather forecasting, I mean that's well established. There are all these measures to quantify predictive skill and so on. And there's a lot of data to verify and validate models that do that, right? Because every couple of days there's a a new forecast that can be validated against what actually happens in the real system. On the longer term, that's much more difficult, of course.
Yeah, but even on the short term, Ken Arrow, who is a very famous theoretical economist, he worked in the Navy in the war, Second World War, as a meteorological person studying patterns in weather and so forth. And he said at the time, we just had a few ships that would send signals. We had very limited amount of information, and our precision was very poor, above, I think he said 2 days, something like that. But he said now we have millions of stations for observing, sending in data and so forth. So we're now up to 4 days, but that's probably somewhat unfair. But it is true, I think, that they, as you said, as we move and extend our horizon just a bit, it really does make the problem enormously more complex. And we've sort of got it under control, I think, for very short horizons. But as you said, for the longer term, and of course, that's been a huge criticism of climate change. You know, are the underlying climatological models for longer term changes, are they precise or not? So, yeah, so prediction, I think, is something which economists would love to do well, but they don't. And the OECD has regularly published a sort of survey of how good their forecasts have been in the past. And the regular answer is not very good. So
you want to see an indication of the forecast uncertainty as well. That would be
sure.
It's also done for weather forecasting. Okay, thanks.
Thanks. Florian wants to come back into.
Yes, if I may. You actually this question of Dan's is raising an interesting methodological issue. So our systems are probably not ergodic. The catastrophes occur only very seldomly. So how on earth are we going to convince people that our models are good?
No, that's, I mean, that's a very profound question, in fact, Florian, a question people ask from time to time. And I'm no more qualified to answer that than a large number of people. But I think your answer is absolutely correct. Your question is absolutely pertinent, because Mervyn King and John Kay have written a book recently called Radical Uncertainty. And Mervyn King was the governor of the Bank of England for a while. And there, what they said was, unfortunately, the nature of the process is such that sometimes we just have to stand back and say, let's try and think about what's going on here, but we don't really know. We just don't know. And he said, but this is very difficult if you're in a political position to say that. People are not happy when you say, well, as our experts say, we don't know what's going to happen. That sometimes you simply have to admit that. But I think that is a real problem. And I don't really know how to get around that, because it's a fundamental philosophical question, as you said. But maybe you have an answer, Florian. What would your answer be?
I think, I mean, it is one of the things I'm worried about. I mean, the reason science is working like it does is that we are trying to analyze small bits and pieces, and we're putting it together again. And if we've got faith in the little pieces, and we've got faith in that we understand how they work together, then we might think that we understand the big one. But it's very hard to check. Sure. Because there's only one run of the world.
No, I think that's exactly the problem. That if you believe that the world is non-ergodic, then you just have one realization to work on. So if it's ergodic, then you just keep observing and so forth. And finally, in the long run, you're going to have some idea of the distribution of the shocks or the changes. But if you really believe that it's non-ergodic, and I can't believe it's other than non-ergodic, then what do you do? As you said, you've got this one realization. What does it mean to actually work on the basis of one realization? So, but maybe at some point somebody will realize that there is some simple answer to that, but I don't understand what that simple answer is.
Well, actually, or the system might be ergodic, but we're still in a transient phase. Actually, this was the answer of Lucretius, if you know that one. He asked himself the question whether the world is young or old, and his answer was the world must be young because so many new things are appearing every day, and it was 2,000 years.
Right, and we haven't moved on much, right? But
Are you saying that essentially the economic models cannot be validated?
Sorry?
So are you saying that models in economics cannot be validated in general?
I guess in some sense, if I mean by validated, do econometric tests to see whether and put confidence intervals, I would claim that that's a very difficult problem. On the other hand, calibration, as people do it nowadays, doesn't seem to me to be much better. I mean, calibration is sort of artificial in a sense, because you simply, and it tends to be in sample rather than out of sample. And what we're really interested in is out of sample forecasting, right? So yeah, I think that, you know, I would probably be killed for saying this, but I don't think we do have very good ways of actually validating in a sensible way. It's not like an engineer when sort of faced with a machine that he's built and so forth. He has a limited set of constraints, and he knows what he's done, and he therefore can sort of validate his theory. And also, of course, you can once you specify what you think is the situation, you can also extend those constraints a lot, so that engineers are not building bridges right at the borderline of sustainability, as it were. You're building bridges with a big margin. And I don't see how easily it is for us in economics to think of the system in that way. So I'm not quite sure what it means to validate. I think what you can say is, do the sort of patterns, excuse me, the stylized facts that we observe, are they somehow reasonably consistent with the sort of models we're talking about? And it's easy with a standard economic model to show you all sorts of things which are not consistent that happen in reality with those models. So at least I think we should have models which allow for the emergence of some of the phenomena we see. But whether that's validating those models, I don't know. Ptolemy, if he was challenged, and his followers were, of course, he would add epicycles all the time. So to keep adding epicycles to their model, and you get reasonable predictions from doing that, but that doesn't mean that the model was right in some sense. It wasn't validated. You know, Copernicus came along, but that's again a bad answer to your question. I'm sorry.
Thanks a lot.
But maybe following up on that, would you say then we should focus more maybe on the qualitative aspects of the model, more on the quantitative parts?
Yeah, the answer again, of course, is going to be yes and no. Yes, because I think what happens is that people are fooled into believing that if I give you a precise numerical solution to something, or a numerical validation of something, that it's then precise. That the fact that I specified, if I say, I think growth next year is probably going to be 2.13, people think, 2.13%, yeah, that's a pretty precise number. Therefore, he must have a pretty precise idea. And I think that's wrong. The fact that we quantify things doesn't necessarily make them more precise. On the other hand, if you don't quantify at all, then you're in a world in which you're doing pattern recognition again. But if you have no structural constraints on the way you're recognizing patterns, how do you say, well, this is a reasonable pattern or not a sensible pattern to look at? So I think on the one hand, we shouldn't fool ourselves into thinking because we quantify something and try and give precise estimates, that it's therefore means that our vision is more precise. On the other hand, we should not sort of simply say, well, anything can happen, guys. you know, I think you probably wouldn't go very far in politics if you said, well, anything can happen, guys. Just let's wait and see.
Okay, I think we've had quite a couple of questions, but maybe we can end here and thank Alan again for a very lovely presentation. Thank you very much.
Thank you, people. And it's always a pleasure to come to Amsterdam, even virtually. So thanks a lot. And I suggest strongly that you remain in contact with Kars and Florian, because I think you have a lot of things to say to each other. So anyway, thanks a lot. Pleasure to see you, and maybe see you one day in 3 dimensions.
Yeah.